Hey friends, कैसे हैं आप लोग? Welcome back to another video. So friends, स्वागत है आप सभी का एक और स्टडी वीडियो में, which is off schedule. I know आज वेडनेसडे है और सचिन तेंदुलकर की रीडिंग का बुक आना चाहिए, बट मैं अपने मामा के यहाँ हूँ, so I don't have that book as of now. So आज सचिन तेंदुलकर की बुक का दिन था, बट आज स्टडी वीडियो आएगा. On Friday we'll get the regular Let's Talk Cricket video. That's a very exciting video. Do watch it. And on Sunday, that is when we again get a video of this study. We'll get that, and from Monday we'll again have, on Monday also we'll have a study video, because Monday is a study video as per the schedule. So Monday को फिर से study video आएगा, फिर Monday से we'll go as per the schedule. This is just a change for this week, but the topic in these two videos that is going to come tomorrow, today and the day on Sunday. Yeah, on Sunday is very interesting and very, very, very important. Okay. Divisibility rules. We learned about division in the last video. Now we'll come to know that how can we identify that if a number is divisible by 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. From 2 to 11, we'll learn all the 10 divisibility rules. In today's video, we'll learn the divisibility rules for 2 to 6. And in the next video, the next 5, 7, 8, 9, 10, I mean 7 to 11. So without any delay, let's go into the video. But before going into the video, the 3 properties of division, I hope you remember, because that's very important to remember when you are doing division or learning divisibility rules. So let's go. Divisibility rule for 2. If a number whose last digit is 2, 4, 6, 8, 0, it is always completely divisible by 2. This means that if any number whose last digit is an even number, that is 2, 4, 6, 8, 0, that number will be divisible by 2. For example, 508, the last digit of 508 is 8, which is an even number. So 508 is divisible by 2. 234, 234. 4 is an even number, it is so 234 is completely divisible by 2. 330. 0 is the last digit and it is an even number, so it is divisible by 2. This is the easiest. Now divisibility rule of 3. A number is completely divisible by 3 if the sum of its digits is divisible by 3. Now a number will be divisible by 3 if the sum of its digits, when we add the digits separately, the sum we get, that should be divisible by 3. For example, 150. Now 150, we have 3 digits, 1, 5 and 0. So 1 plus 5 plus 0, which is 6, which is divisible by 3. Hence 150 is divisible by 3. 300. Now the sum of digits is 3 plus 0 plus 0, which is equal to 3. And of course 3 is divisible by 3. So 300 is divisible by 3. 489. Sum of digits is 4 plus 8. 4 plus 8 is 12. 12 plus 9 is 21. So 21 is divisible by 3. And if you don't know the table of 3, which you should know, you can again check in 21, 2 plus 1, which is 3, and 3 is divisible by 3. So 21 is divisible by 3, and hence 489 is divisible by 3. Now divisibility rule of 4 is also very easy. If the last 2 digits of a number are zeros or are divisible by 4, the number is divisible by 4. So if a number is divisible by 4, it has to be divisible. The last 2 digits of the number combined will make a number, and that number should be divisible by 4, or the last 2 digits should be a 0. For example, 508. So 508, the last 2 digits of 508 are 0 and 8, which make 8, which is divisible by 4. 508 is divisible by 4. 100. Oh my God. The last 2 digits are 0. Yes. They are 0. 100 is completely divisible by 4. 324. The last 2 digits are, sorry, this is a bit, there's an error in this. last two digits are 2 and 4, which is divisible, which is 24, which is divisible by 4, and hence 324 is divisible by 4. Now let's go to the divisibility rule for 5. I think we'll complete all in this video, and if we complete all in this video, I really don't know what I'm going to upload on Sunday. Now divisibility rule of 5 for 5. If a number whose last digit is 0 or 5, it is always completely divisible by 5. This is very easy. In 2, it was even number. The last digit should be an even number. In this, it should be a 0 or a 5. 500, last digit 0, divisible by 5. 965, last digit is 5. Hence, 965 is also divisible by 5. And 345, divisible by 5. 5 is divisible. The last digit is 5. 345 is divisible. Now 6. This is a bit complicated, but not that. Now, because now the rules 6, 7, and 11 are a bit complicated. A number is completely divisible by 3 if the sum of its digit is divisible by 3. Okay, sorry. A number is completely, oh sorry, this is the wrong slide maybe. Yeah. If a number who is divisible by 2 or 3, it is always completely divisible by 6. This simply means if a number is divisible by 6, if a number is divisible by 2 and 3 both, it is divisible by 6. Like 630. Listen to me very carefully. How do we write and how do we solve this? If I want to check that what if 630 is divisible by 6 or not. If 630 is divisible by both 2 and 3, it is divisible by 6. Now we'll check to the divisibility of 2 and 3 one by one. First, the divisibility of 2, which is last digit should be 2, 4, 6, 8, and 0. Right? Here's the last digit 0. Hence, the number is divisible by 2. Now, divisibility of 3. Sum of digits is 6 plus 6, 3 plus 0 is equal to 9. Hence, 9 is divisible by 3. So, 630 is divisible by 3. And because since 630 is divisible by both 2 and 3, it is also divisible by 6. And now the second example, which is 990, last digit 0. So it is divisible by 2 also. And sum of digits is 9 plus 9 plus 0, 18, which is divisible by 3. So 990 is divisible by 3. And since 990 is divisible by both 2 and 3, the number 990 is also completely divisible by 6. Now I was planning to make two parts. But I think that we'll complete it in this video. Or if we don't, we can make for 2-3 numbers in the next video also. So let's further to 7th. Now this is complicated. So it is a bit difficult, but if you understand, it's very easy to solve. Very carefully. First, don't go towards the examples. Just see the first, the divisibility. So just read that and listen to it. If a number is divisible by 7, then the difference between twice the unit digit of the given number and the remaining part of the given number should be 7, or it should be equal to 0. So for a number, if it is divisible by 7, then we have to first check that the difference between the number, the double of the number on the ones place. So we have to find the difference between twice the number on the ones place of the number and the remaining 2 digits, or how many digits we have of the number. We have to subtract them, and then if that subtraction, the difference that we get, if that is a multiple of 7, then we come to know that if it should be a multiple of 7 or it should be a 0, then that number will be divisible by 7 completely. First example is 798. We know that the unit digit of 798 is 8. We double it first. 8 plus 8, 8 into 2, 16. Remaining part is 798. 8 is gone. 79. 79. Now we get the difference. 79 minus 16, which is 63. So difference is 63. And since 63 is divisible by 7, 798 is also divisible by 7. And if we want to check the divisibility of 63 by 7, we take the unit digits 3, we double it, 3 into 2, 6. Then the remaining part 6, 6 is the doubled, the twice the unit digit of the given number, that is 6, 6 minus 6, which is 0. So 63 is divisible and hence 798 is also divisible. 994. The unit digit of 994 is 4. If we double it, it's 4 plus 4 or 4 into 2, which is 8. The remaining part is 99. Now 99 minus 8 is 91. And we know that 13 sevens is 91. Or we can do that, the difference is 91. So because 91 is divisible by 7, 994 is divisible by 7. And because 1 plus 1 is 2 and 9 minus 2 is 7. So we also can check that 91 is divisible by 7 or not. Because 91 is divisible, 994 is also completely divisible by 7. This was probably the most complicated rule of all the divisibility rules. But if you understand, you can easily solve. Now, divisibility rule of 8, 9, 10 is completely easy. So let's go through it quickly. Divisibility rule for 8. If the last 3 digits of a number are divisible by 8 or are zeros, the number is completely divisible by 8. For example, 4,344. The last 2 digits are 3, 4, 4. Now, how we can check that if they are divisible? You know division. You know division. We have already learned division. That was 2 digits divided by 1 digit. I know. But we all know that the formula will be same whether it's 3 digit by 1 digit, 4 digit by 1 digit, or 5 digit by 1 digit. It does not matter. Now let's go further. So the last 3 digits of 4,344 is 344. Now 8. Now we take 30 of 34. We take. Listen to me very, very carefully. Okay. Yeah. We don't take 4. We only take 34. Nearest number 34 that comes in table of it is 8. 4 is 32. So 4 and 32. We are 2 is left. 2 and 4. 24. 24. Now that was 4 and now it is 3. 43 adds a 344. You can also do long division method, which we all know. And 344 is divisible by 8. Hence 4,344 is also 1200. Last digits 200. 200 is definitely divisible by 8. And hence 1200 is also divisible by 8. There's error here. It's 1200, not 100 in the last line. 6,400 is divisible by 8 because the last, oh sorry, there's another error over here. I'm really sorry for these errors because I think the PPT PowerPoint did not save them, or maybe I made a mistake. But let's focus that 6,400. Okay, so these are the 3 digits. 400 is definitely divisible by 8. We all know that because it's common sense. 40 is divisible, so 400 has to be divisible. And 400 is divisible, which are the last 3 digits. So hence 6,400 is also divisible. And over here, 6,320 is also divisible because 320 is divisible by 8. Now the next rule. Okay. Divisibility rule for 9. This is same as 3, so I'll not take much on this. The sum of digits should be divisible by 9. So 369, 3 plus 6, 9, 9 plus 9, 18. Sum is divisible by 9 and hence the number is divisible by 9. 10 is also maybe probably the easiest. The last digit is 0 and the number is divisible by 10. In 2 it was the last digit should be 24680. In 5 it should be a 5 or a 0. Here a 0 is what you want at the last digit at the ones place and the number is divisible by 10. 500, 960, 340 and a ton lot of examples are there. Now the second most difficult as for me to learn was the divisibility rule of 11. Very carefully we have to learn, because I have only given one example here, but there are steps to solve this. In seventh one also, if I take you to the slide of seventh, these are the steps. In example one, I have the example takes 4 lines. These 4 lines are the steps. First we have to take the unit digit, then we have to double, then we have to take the remaining part, then we have to take the difference of both, and then we have to check that if the difference is divisible, the number is divisible, and then we have to write the final statement. Now here there are 3 steps, and then we have to write the final statement. Now listen to me carefully, very carefully. Listen, see, and understand. If the difference of the sum of alternative digits of a number is 0 or divisible by 11, then that number is divisible by 11 completely. Example 990. The first step is, now every number has 2 places, 3 places, 4 places, or 5 places. 990 has 3 digits. 990. HTO 100 tens ones. So let's take odd places and even places. That is, first we'll take 0, then we'll leave 1 space and we'll take 9. So like this, if there are 4 digits, it's the ones place, then the hundreds place, and then if there is, 10,000 and further. So group the alternative places, the digits on the alternative places together. So for example, in 990, here we have 990. So 0, we leave 9 and we take 90. So 90 is the group of odd places and 9 is the group of even places. Okay, we group the number in odd places and even places together. So all the numbers which are on odd places and all the numbers which are on even places. So how do we come to know that odd and even? So take one place value, place like ones O, then leave tens T and come to hundreds H. Leave 1 digit in between and then group them accordingly. Step 2 is we have to take the sum of the digits. So 90 is one group and 9 is another group. 9 plus 0 is 9 and 9 itself is 9. So the sum is 9 and 9. Then the difference between the sums of the digits in the alternative place of a number, or the difference between the sum of alternative digit of a number, should be 0 or divisible by 11. Hence we come to know that 990 is divisible by 11 because difference is 0. I know this is complicated, but just read the steps. Group the number in 2 places, leave the alternative digits, group them together. Okay, take the sum of that groups, like 9, we have 90 with some, we add 10, we have 9, we leave that because it's a single digit. If it is the number like 9,990, triple 90 will not be divisible, man. Maybe 880 we can say. Yeah, why not 880 we can also say. 880, 8 minus 8, 0, 8 and 0. That's it. We understand that. That's very easy. Then we take the sum of digits of each group, 9 plus 0 and 9. Some are 9 and 9. Then we find the difference between the sum that we got by adding the 2 places which we grouped. Then the difference of sums that we get is what matters, and that should be divisible by 11, or it should be a 0, the difference. Then only we can say that divisibility rule for 11 is complete or is there, and the number is completely divisible by 11. Now I know this was a long video, but thank you for watching, and I hope you understood all the 10 important divisibility rules. 1 is not a number we should know because 1 is divisible by every number. We all know that. Every number is divisible by 1. So now that is about this video. अगर आपको वीडियो अच्छी लगे तो वीडियो को लाइक करें, शेयर करें और मेरे चैनल को सब्सक्राइब करना ना भूलिएगा। और अगर आप चाहते हैं कि मैं ऐसे और अच्छे वीडियोस बनाते रहूं तो इस वीडियो में मैं एम करता हूं 20 लाइक्स का। जल्दी से लाइक बटन दबा दीजिए। इस वीडियो में इतना ही, मिलते हैं अगले वीडियो में, तब तक के लिए Stay home, stay safe, and goodbye. See you soon. Jai Hind. Goodbye.